The decibel, dB, can be used to describe electrical or acoustical levels. The technical description of the decibel can be defined as a unit for expressing the ratio between two physical quantities, meaning the electrical and acoustical characteristics of signals, and signal changes. The decibel is also used for measuring the relative loudness of sounds, which includes sound pressure and intensity. The decibel is also highly complicated, so we will only cover the essential information you need to know in order to understand the fundamental concepts related to this subject. What you should understand about the decibel and sound pressure level. A +1 dB change in sound pressure level is the smallest perceptible change that can be heard by the human ear, and is extremely difficult to hear when listening to music. Not many can actually hear this change. A +3 dB change in sound pressure level is the minimal practical change that can be easily heard by the majority of listeners. This is accomplished by doubling the power. A +6 dB change in sound pressure level is very easy for listeners to hear. This change is considered the goal for any changes in system levels and is accomplished by increasing the power by a factor of 4, which would be 4 times the power. A +10 dB change in sound pressure level would be considered twice as loud, and would require an increase of 10 times the power. To half the loudness, it would require a -10 dB change in sound pressure level and would require a decrease of 10 times the power. Understanding how the decibel relates to amplifier size. A +3 dB change in sound pressure level is the minimal practical change that can be easily heard by most listeners. To produce this +3 dB change, you would need to double the wattage of your amplifier. For example, if you have a 200-watt amplifier, you would need a 400-watt amplifier to get the extra 3 dB of sound pressure level. That's all doubling the amplifier wattage will give you. With this being said, a 300-watt amplifier and a 350-watt amplifier would be relatively the same. A +6 dB change in sound pressure level is easier for listeners to hear, and is considered the goal for changes in system levels. To produce a +6 dB change, you need to increase the power by 4 times the current wattage of your amplifier. For example, if you currently have a 200-watt amplifier, you would need an 800-watt amplifier to get the extra 6 dB of sound pressure level you are requiring. If you need your system to be twice as loud, this requires a +10 dB change in sound pressure level. To produce a +10 dB change, you need to increase the power by 10 times your amplifier's current wattage. For example, if you currently have a 200-watt amplifier, you would need a 2000-watt amplifier to get the extra 10 dB of sound pressure level. You would need to hear the system as twice as loud. Best practice is to design the proper amplifier wattage into your system from the beginning. This is the easiest and least expensive way of ensuring your sound system will provide the required levels that are needed. Understanding how to match amplifiers and speakers, and building in the proper headroom will help you adequately design a system without having to deal with the high costs of bringing in a sound engineering company to design a system. If you follow these simple steps, you will be able to design a system that will get you the levels you require. Here are some basics that you need to know to get started with designing your sound system. What size amplifier will you need? It depends on your speaker's specifications. You would first need to look at the speaker's data sheet and find the specification continuous power rating. The amplifier ratings that are important for audio technicians to understand would be the RMS mean power, which translates to root mean square / continuous, and the peak power ratings. The RMS amplifier power rating will be the most important specification to consider when you are attempting to match up amplifiers and speakers. Peak power ratings basically signify short bursts of amplifier power, and not any type of sustainable level. The RMS continuous power rating is the rating that is needed in order to find and match the correct speakers to the amplifier. The RMS rating is usually stamped on the back of power amplifiers. It's always best practice to review the manufacturer's data sheets to confirm the RMS continuous power rating. Similar to amplifiers, RMS mean power, or root mean square power handling, refers to how much continuous power the speaker can handle. The peak power handling value refers to the maximum power level the speaker can utilize in short bursts. For example, a speaker with a 30-watt RMS rating and a peak rating of 60 watts means that speaker can comfortably run with 30 watts of continuous power, with occasional bursts of up to 60 watts. Many speaker manufacturers will provide both values for a given speaker. Both values are important. Check out the specification notes of an electro voice speaker on the next slide. This is what you would usually see in a speaker specification sheet. Most of the time it will read power handling, continuous, program, peak, but many times will only read power handling, continuous, peak. On this specification the continuous rating is 400 watts. This means that this is the average wattage that will be supplied to the speaker at a sustained level. The peak rating is shown as 1600 watts, and represents the sudden or momentary bursts of wattage that the speaker can handle. The program rating is shown as 800 watts, and represents the manufacturer's recommended amplifier wattage to use with the speaker to allow proper headroom. The specification sheet can show the ratings in any of the following ways. If the program rating is not shown, it is best practice to double the speaker's continuous rating to get the recommended amplifier wattage. Sometimes, you may just have to read the information stamped on the speaker to get the specifications you need. It may not give you all the ratings, but as long as you have the power capacity and how many ohms, it may be all that is needed.